In this video, I'll show you how to integrate using inverse trigonometric substitution. This is question 3. The function that we will be integrating in this video is shown right here, where we have to take the integral of the square root of x squared minus 16 over x to the power of 6. Now you'll notice in this function, there exists a component that is similar to this expression right here. This is the x squared, and 4 represents your a. 4 to the power of 2 is 16. So as a result, what we have to do to integrate this is set x equal to whatever our a is. In our case, it's 4 secant theta. What we do next is take the derivative of this equation. And if we do that, we end up with dx is equal to 4 secant theta tan theta. This is the derivative of secant theta. In fact, it's a known derivative, and that's how I knew it so quickly. And don't forget d theta. So we just found out what dx is equal to, and we can replace this dx with this expression. And we also know what x is equal to. We set it as 4 secant theta. So let's go ahead and rewrite this function using what we just found. We have the integral of the square root 4 secant theta, and this is being squared, minus 16, over x to the power of 6, which is 4 to the power of 6. I'm just distributing the 6 to each of these components, and I can do that. Secant to the power of 6 theta. And of course, our dx in this case is, now that we have our whole function in terms of theta, next we simplify. And here's how to do that. First of all, I'll distribute this power of 2 to the 4 and to the secant theta function. And if I do that without having to rewrite everything, I end up with 4 to the power of 2 secant squared theta. And 4 to the power of 2 is 16. The next thing that I'll do is cancel out one of the 4's down here with this 4 up here. And this over here becomes 4 to the power of 5. And the same thing goes with this secant and this secant. That becomes secant to the power of 5 theta. Furthermore, I will factor out a 16 from the radicand shown here. The square root of 16 factored out, secant squared theta minus 1. I'm factoring out a 16 from this term and a 16 from that term, and that gives me secant squared theta minus 1. And we're left with 4 to the power of 5 secant to the power of 5 theta. Now remember, if you have a product underneath a radical, as we do here, we have 16 times secant squared theta minus 1, the radical can be distributed to each of those components. So I can distribute this radical, this square root, to the 16, which becomes 4. And I can also distribute this radical to the secant squared theta minus 1. So I'll do that in the next step. So 16 square rooted is 4 multiplied to the square root of secant squared theta minus 1. Now one thing that I want you to be aware of is that when we followed this table, they told us what to set our x to, and they also told us the identity to use. Notice secant squared theta minus 1 is equal to tan squared theta. So let's use that instead. Times, now everything else stays the way it is. The next step is to apply the square root to the tan to the power of 2 theta. So instead of rewriting everything, I'm just going to erase this and replace it with simply tangent theta. And this 4 will cancel out with another 4 at the bottom, where we are left with the integral of tangent squared theta d theta over 4 to the power of 4 secant to the power of 5 theta. What I'll do next is pull out the 1 over 4 to the power of 4 outside of our integral, where we have 1 over 4 to the power of 4. Now what also helps at this stage is realizing what tan is equal to. Remember, tangent is equal to sine over cosine. So what I can do is replace tangent to the power of 2 theta with sine over cosine to the power of 2. So I'll continue my work down here, where I have, and I'll show you an arrow here just to show you where I'm leading, 1 over 4 to the power of 4 And I will be replacing this with sine squared theta over cosine squared theta, d theta, over 1 over cosine to the power of 5 theta. Now, if you're curious about this, remember, secant is a reciprocal function that is equal to 1 over cosine. So I replace this with 1 over cosine to the power of 5 theta. And if I rearrange this part of my function, I end up with, let's continue. Of course, now we can cancel out some of these cosines. We have 5 up here and 2 down here. So this becomes a 3. And we're left with this function, 1 over 4 to the power of 4, the integral of sine to the power of 2 theta, cosine to the power of 3 theta, d theta. What you have to do now, because now we have two trigonometric functions being multiplied together and we have to find their integral. And I do have a video dedicated on this, but what we did in one of our videos is we split up cosine to the power of 3 theta into cosine to the power of 2 and cosine. So I'll do that here. Cosine squared theta, we use this identity, 1 minus sine squared theta, where I can replace this now with 1 minus sine squared theta. And now we have to set sine as our u. If I set sine as my u and take its derivative, du is equal to cosine theta d theta. I'm going to solve for d theta because eventually I want to replace that. And I end up with the following. Now I'm going to rewrite my function in terms of u. 1 over 4 to the power of 4, u to the power of 2 times 1 minus u to the power of 2 cosine theta du over cosine theta cancels out, and we have an easy function to integrate. So I'll expand this first, where I have u to the power of 2 minus u to the power of 4. The integral of u to the power of 2 is u to the power of 3 over 3, and the integral of this is u to the power of 5 over 5. And of course, we need to add the plus c. And now we have to replace the u's back with the signs. And if you do that, you should end up with this. And remember, our original function was in terms of x, so we have to replace that with what x is equal to. And remember, we set x as way back here for secant theta. I need to solve for theta. And if I do that, I end up with x over 4 is equal to secant theta. Secant is a reciprocal function of cosine, and cosine is adjacent over hypotenuse. Therefore, this has to be our hypotenuse, and this has to be our adjacent. That being said, if we were to draw a right triangle, and this part right here would be our x, or hypotenuse, and our adjacent would be 4. So in terms of sine, sine is opposite over hypotenuse. So we need to find our opposite now. And we can use the Pythagorean theorem. If we use the Pythagorean theorem, we end up with this. X squared 16 plus o to the power of 2. X squared minus 16, the square root is our opposite. And now that we found that, we can finally find our final answer. But first I want to multiply this 1 over 4 to the power of 4 into these two terms. It looks better at the end. If you've done it correctly, it should look like this. Sine using this triangle is opposite over hypotenuse, so we end up with x squared minus 16 square rooted over x to the power of 3, this part, minus 1 over 4 to the power of 4, and the same thing here, plus c. And yes, this was a very, very long question, but it was worth it at the end. This right here is the integral of this function. Take a look at your work. And so there you have it. That is how to integrate using inverse trigonometric substitution.